In this video, I'm going to solve the last question from chapter 15, oscillation. Okay. Suppose that the simple pendulum consists of a small bob which have the value of 60 grams. So what is the mass of the bob? You have the simple pendulum, and as we know, the simple pendulum has a bob and its mass is mentioned here as 60 grams. So what is the mass of the bob? The mass of the bob is 60 gram, which is equal to 60 multiplied by 10 power minus 3 kilogram, right? Okay. So 60 gram bob at one end of the cord of negligible mass. So it is connected to a string, right? If the angle theta between the cord and the vertical is given by the equation theta, which is equal to 0.08 rad, cosine of 6.80 radian per second multiplied by t plus the angle, right? So now we have to find the answer for two questions. In the first part, we are going to calculate the length of the pendulum, that means the length of the cord. And the second part, we are going to calculate what is its maximum kinetic energy, right? Okay, we just go one by one. First of all, I am going to rewrite this equation which is given in the question of the angle. So the angle theta is given by 0.08 rad cosine of 6.8 rad per second multiplied by t plus the phase angle, right? Okay. As we already know, when you just compare this equation with the wave equation, the first one is the amplitude. So we take this is the amplitude theta m. Clear? And what is this part? This 6.8 indicates the angular frequency omega, right? Right? Okay. Now, for finding the length of the pendulum, I am going to use the relation connecting the frequency with length. So what is the frequency relation with the length? As we already studied in the theory, the omega, which is equal to square root of g over L, right? This is the relation we studied in the theory. So this is the relation connecting the angular frequency with the length of the pendulum, but g is the 9.8 acceleration due to gravity. Now, by using this relation, we are going to find what is the length of the pendulum L. So for this, we have to squaring that equation both sides, left hand side as well as right hand side. So if you square the left hand side, you will get omega square. If you square the right hand side, what will happen? The square root will gone. Am I right? So by that, you will get only g over L. Now I'm going to rearrange this equation in terms of the length. Therefore, length L, which is equal to g over omega square, right? Now we have the value for omega from the equation. So from the equation, what is our omega? Which is 6.8 rad per second, and g value is the constant 9.8. So I'm going to substitute the value here for finding the length of the pendulum. Therefore, the length of the pendulum L, which is equal to 9.8 divided by the angular frequency, which is 6.8, right? 6.8 square. That's very, very important. Okay. Now I have to calculate the value of the length, which is 9.8 divided by 6.8 the whole square. So I got the answer as 0.211. So the length L is 0.211 meter. So this is the answer for the first part, right? Okay. Now we have to answer the second part. What is mentioned in the second part? We are going to calculate the kinetic energy, maximum kinetic energy. So if you want to calculate the maximum kinetic energy, the most important thing, we have to find what is the maximum speed, right? Without maximum speed, we can't use the kinetic energy. So for that, we have to use the maximum speed equation, which we already studied in the theory, which is given by the relation the maximum speed. So this is our maximum speed, right? Okay. How to find the maximum speed? We already have the relation V max, which is equal to angular frequency multiplied by xm, right? And if the pendulum is vibrate, if the pendulum is oscillates, we can easily find the value of this xm by using the arc formula. By using the arc formula. For example, if you see, this is the pendulum, this is the equilibrium position. When it comes to this place, with respect to small angle theta m, and how much distance it's traveled to a distance of xm, right? And this is the length of the pendulum. By that we can easily find the value of the xm by using the arc rule, L multiplied by theta m, right? This value multiplied by this value, which will give the answer for the amplitude, right? So what I am going to do, in place of this xm, I am going to substitute this value, this equation. By that, our maximum speed equation will given by the new relation omega multiplied by L multiplied by theta m, right? Now L value we already found from the first part. Omega is already is given in the equation because we have all these three values. We just go back to the equation. So what are the things? L we have 0.211, and likewise omega we have 6.8, and likewise we have theta m value is 0.08. So that means we have all these three values. The only thing we have to substitute in this equation for getting the value of the maximum speed, right? So I have to substitute the value of this omega, which is 6.8 multiplied by the length value which we found in the previous part is 0.211, 0.211 multiplied by what is our theta m? Our theta m value is given in the question as 0.08. 0.08. So I'm going to multiply everything. By that we can easily find what is our maximum speed. So 6.8 multiplied by 0.211 multiplied by 0.08. I got the answer as 0.115. What's the answer? 0.115, and its unit is meter per second because it is our speed, maximum speed, right? Once we identified the maximum speed, we can easily find the answer for the kinetic energy, because we know the rule for the kinetic energy, which is half mv square. That is the formula for calculating the kinetic energy. So now I am going to find the answer for the kinetic energy. Therefore kinetic energy rule is given by half m speed maximum square. Now I am going to substitute the value 1/2 multiplied by the mass is already mentioned in the question as a 60 gram, right? So we just go to the question. See here, we have 60 gram. I'm right. So I'm going to use this value in this equation. So by that we can easily calculate the value of the kinetic energy. So 60 gram means 60 kilograms. I have to convert 60 multiplied by 10 to the power of -3 multiplied by what is our maximum speed? 0.115 square. So I'm going to multiply again, half multiplied by 60 10 power -3 multiplied by 0.115 square. So I got the answer as 3.96, 3.96, so 97, because we got 3.967. So I can write this value as 3.97 multiplied by 10 power minus 4. And what's the unit for the energy? Kinetic energy, it's a joule, right? So kinetic energy, we got 3.97 multiplied by 10 power minus 4 joule. So this is the answer for the second part, right? This is our answer for the second part. That's it. Thank you.